In some breaking news, scientists have managed to stitch together one of the highest resolution interior images of the Earth's core mantle boundary. And their analysis reveals undiscovered ancient ocean floor hidden within the mantle. This layer is a thin but very dense part of the mantle, which sits around 2,900 kilometers beneath the crust, right where the metallic outer core meets the mantle boundary known as the CMB. And they do this imaging using seismic waves. This is known as seismic investigations, where they use seismic waves which pass through the Earth, which reflect and refract on different layers, giving us a nice image, sort of how an ultrasound works during a pregnancy. In this study, scientists used 15 seismic stations in Antarctica, which mapped out the seismic waves from earthquakes across 3 years. And by analyzing thousands of seismic recordings, they were able to create a very high-resolution image of the ultra-low velocity shear zones. And for those unaware who may have not watched my previous videos on seismic imaging, there are two main types of body waves. We have primary waves and shear waves or secondary waves. Primary waves have the ability to go through solids, liquids, and gases and are compressional waves and travel much quicker. S waves, on the other hand, can't travel through liquids. Therefore, if there are any medium or major density changes, the different waves will reflect and refract and also travel slower or quicker depending on the medium. And that's how they make these images behind me, where they can look at the velocity changes of these waves as they pass through the Earth. These ultra-low velocity shear zones, also known as blobs because they are literally floating around in the mantle, have been known previously, but not to the extent as this study shows. For example, all of the orange ones are the new ultra-low velocity shear zones that were detected in this study. And when they were mapping these shear zones, they noticed that some of the blobs were nearly 5 times taller than Mount Everest. And one of the reasons why the ocean floor may even reach down to the core mantle boundary is due to the convection currents that exist within the mantle, where you have upwelling and downwelling flows causing these ultra-low velocity zones to not only gather in certain places and accumulate, as you can see here in the two piles, but also scatter between them. And it's the scattering which creates this very complex layer of ultra-low velocity shear zones. It's pretty fascinating that scientists can make images as complex as the ones that we've seen in this video just by using the arrival times of P waves and S waves. As more studies are done across the globe, moving away from just Antarctica to other continents and using the P waves that you see in the image behind me, we may come to a point where our mantle has to be compartmentalized into separate layers due to the pure number of these ultra-low velocity shear zones. And whilst it's quite easy to use a cake as an analogy for the layers of the Earth, we're starting to realize that it's a lot more complex than previously thought. And hopefully research like this can help us to determine how volcanic eruptions occur near the crust. Thanks for watching.